So hi guys, welcome again to another video, and for this video I'll be summarizing again the chapter 4, which is the network access. So let's start. Excuse me. So we have the type of connection, which is the Ethernet switch, the internet connection, and the embedded antenna. So for the Ethernet switch, we have 4 ports, and for the internet connection, we have 1 port, and for the embedded wireless antenna, we have 2 antennas for the router. So for the next one, we have the functions. So the functions here are the physical components, encoding, and the signaling. So for the physical components, we have here it is the electronic hardware device, media, and other connectors that transmitted and carry the signal to represent the bits. So the hardware components such as NIC, interface, and connectors, cable materials, and cable designs are all specified in the standard associated with the physical layer. The various port and interface on the Cisco 1941 router are also example of the physical components with the specific connectors and pinout resulting from the standard. So we have now the encoding, and it is a method of converting a stream of data bits into a predefined code, and codes are groupings of bits used to provide a predictable pattern that can be recognized by both the sender and the receiver. So in other words, encoding, the method or pattern used to represent data, digital information, and it is similar on how Morse code encodes a message using a series of dots and dashes. So for the next one, we have the signaling. So it is a physical layer that must generate the electrical, optical, or wireless signals that represents the 1 and zeros on the media. Excuse me. And the media, the method of representing the bits is called the signaling method. So the physical layer standards must define what type of signal represents a 1 and what type of signals represents a 0. This can be simple as change in the level of an electrical signal or optical pulse. So let's proceed to the next one. We have excuse me. We have the unshielded twisted pair or the UTP. So we have here it is a most common networking media, and that is terminated as RJ45 connectors, and it is used for interconnecting network hosts with the intermediate networking devices such as switch and routers. So excuse me. The UTP cable consists of 4 pairs of color-coded wires that have been twisted together and protects from minor physical damage, and it encases flexible plastics shred, and we have the outer jacket, which is protects the copper wire from the physical damage, and we have the twisted pair, which protects the signal from interference, and the color coded plastic insulation, it is a electrically isolated wires from each other and identifies each pair. So for the next one, we have the shielded twisted pair. So excuse me, it provides better noise protection than the UTP cabling. So compared to the UTP cable, the STP is significantly more expensive and difficult to install. Like the UTP cable, STP uses RJ45 connector, so it combines techniques of shielding to encounter EMI and RFI, and wire twisting to counter crosstalk. To gain the full benefit of shielding, STP cable are terminated with special shielded STP data connectors. So if the cable is improperly grounded, the shield may act as an antenna and pick up unwanted signals. So the last one, we have the coaxial cable. So the coaxial cable, or coax for short, and gets the name from the fact that there are two conductors that shares the same axis. So here we have, for the coaxial cable, we have excuse me, the outer jacket, the braided copper shielding, the plastic insulator, and the copper conductor. So there are different types of coaxial connectors. We have the BNC, the N-type, and the F-type. So we have the common physical one topology. So we have the point-to-point. So it is a simplest topology that consists with a permanent link between two endpoints, and for the reason this is the very popular one topology. So for the next one, we have hub and spoke. So one version of the star topology excuse me, in which the central site interconnects branch sites using point-to-point link. So for the last one, we have the mesh, and it is a topology that provides high availability but requires that every end system be interconnected to every other system. So it is a administrative and physical cost can be significant. Each link is essentially a point-to-point link to the other node code. So let's proceed to the next one. So we have here the physical LAN topologies. So excuse me. So we have the star, the extended star, the bus, and the ring. So first, let's just define the star. So the star is the end devices are connected to a central administrative or intermediate devices. The early star topologies interconnected end devices using the Ethernet hubs. So, however, star topologies now use Ethernet switches. The star topology is easy to install, very scalable, easy to add and remove end devices, and easy to troubleshoot. So, additional for this information in the star, it is a implementation of a spoke hub distribution paradigm in the computer networks. Every host is connected to a central hub. In its simplest form, one central hub acts as conduit to transmit messages. Star network is one of the most common computer network topologies. So let's just like the for the extended star, we have just doubled the star topology, and it has two star topology in the extended star. So now let's proceed to the bus topology. So the bus topology, all end systems are chained to each other and terminated in some form on each end. So infrastructure devices such as switch are not required to interconnect the end device. So the bus topology using coaxial cable were used in legacy Ethernet networks because it was inexpensive and easily to set up. So that's the type of the bus topology, and it is a network topology in which nodes are directly connected to a common hub duplex called the bus. And nodes are connected to a single cable, and the cable which is the nodes connect is called the backbone, and if the backbone is broken, the entire segment falls. So I'll be adding here in the extended star. So additional Ethernet switch interconnected to another star topology. An extended star is an example of hybrid topology. So for the last one, we have the ring. So end system are connected to their respective neighbor forming a ring. So, unlike the bus topology, the ring does not need to terminate it. Ring topology were used in legacy fiber distributed data interface or the FDDI and token ring networks. So, in additional, excuse me, it is a network topology which each node connects to exactly two other nodes, forming a single continuous pathway for a signal through each node. A ring data travels from node to node, with each node along the way handling every packet. So it is a network configuration which device connection to create a circular data path. Each network device is connected to two other like points on a circle. Most of the ring topologies allows packet to travel only in one direction, called the unidirectional ring network. So let's proceed to the frame field. So we have the header, the packet or the data, the trailer, and for the header we have frame start, addressing, type, and control. And for the trailer we have detection, error detection, and frame stop. So for the frame start, it is used to identify the beginning and the end limits of the frame. And for the addressing, it indicates the source and the destination nodes in every media. So we have the type, it identifies the layer 3 protocol in the data field. And we have the control, identifies a special flow control service such as quality of service, and the quality of service is used to give forwarding priority to a certain type of messages. Data link frames carrying voice over IP packets normally receive priority because they are sensitive to delay. And we have the data, which contains the frame payload, for example the packet header, the segment header, and the data. So for the error detection, these frame fields are used for error detection and are included after the data to form the trailer. And for the frame stop, it is the end limits of the frame. So that's all for this video. Thank you for watching. See you again on my next video.